One of the assumptions of a good regression model is that the data of the regression model have to be free from heteroscedasticity. Otherwise, we can say that the data have to be homoscedastic. Heteroscedasticity means in the data, there are some data points those have more variability or more dispersion than most of the data. This is something just like this. Here we see in this data set, some of the data, this data have more variability than most of the data points. This is called heteroscedasticity, and this is not expected for a good regression model. Which is expected for a good regression model is just like this. In this case, we see the data points have similar dispersion from their standard line and showing similar variability of their dispersion from the standard line. This is homoscedasticity, and this is expected for a good regression model. So we need to test heteroscedasticity, and the mostly used test of heteroscedasticity is Brisk-Pagan-Gottfried test, which is quite complex to test in SPSS because it needs to write some commands and it's time consuming. So what I do is I test heteroscedasticity in Eviews, and in this video I'm going to show you how you can test heteroscedasticity in Eviews. Here is my dataset in Eviews, and I have 3 independent variables x1, x2, x3 and 1 dependent variable. Let's open them in a group. What we have to do first is to run a normal regression. To run a normal regression in Eviews, we have to click on quick and then click on estimate equation. Here, at first, provide the name of the dependent variable. In this case, y is my dependent variable, so let's write y, then I space and write c. C stands for constant, and then again a space, then there will be the independent variables x1, then a space, then x2, again a space, and x3, then click on OK. This is my regression outcome. What I have to do is just to click on view and go to residual diagnostics, and from there click on heteroscedasticity test. In this window you will find a number of tests. With those you can determine heteroscedasticity in your data, but as I said before, most popular test is Brisk-Pagan-Gottfried test. So select Brisk-Pagan-Gottfried and click on OK. Here is the outcome. It has 2 parts, the upper portion and the lower portion, but to determine heteroscedasticity we need the upper portion only. In the upper portion you will find a term called probability of chi-squares. The term is probability of chi-squares. Look at the value of this probability of chi-squares. The guideline is that if this value is less than 0.05, it means the data has heteroscedasticity. Otherwise, if this value is more than 0.05, the data has homoscedasticity. In my case, in this data set, we see the probability of chi-square is 0.4462, that is greater than 0.05. So we can say my dataset has homoscedasticity. and it's good for a good regression. So in this way you can determine whether your dataset has heteroscedasticity or not. And if you have any question, feel free to write in the comment section. And finally, thanks for watching.